Hello to all. This is Abundance for All, Sense and Sciences, and I'm Desiree Driesenaar. And we are part of a hackathon, Energy Landscape of the Netherlands, energy economy, I must say. And our team is going to do that with the GIELIS Superformula. And that is what I will share a little bit about. Let me share my screen. This is the hackathon for the coming days. The Synergy Hackathon in Delft in the Netherlands. We are redesigning the Dutch landscape as part of the European landscape, of course, because we always do our designs in bioregions. We use biomimicry as a formula, and this is our team: Professor Johan Gielis, Douwe Jan Schrale, Andreas Krusakin-Liboska, and Desiree Driesenaar. We are redesigning the energy landscape, the energy economy landscape of the Netherlands with GIELIS Superformula. And that is what I want to talk to you a little bit about, because it's good to have a little bit of background. GIELIS Superformula was discovered in the year 2000 somewhere, and in 2003, Johan Gielis wrote a book about it, Inventing the Circle. He has written many papers. He is a scientist. He is a mathematician and a botanist. And he does everything with shapes of plants. But apart from being really a bamboo enthusiast, and his in vitro cultivations of bamboo are famous, he is also a mathematician and a geometrist. And that is what we will redesign with biomimicry, because biomimicry is pure geometry, is pure math. So between 2003 and this year, 2024, 20 years have passed. And in these 20 years, a lot has happened with the GIELIS Superformula, because it has entered science big time. And it is used in many sciences. In the psychology, in neurosciences, in biology, ecology, but also in technology, in algorithms, in VR, AR. Everything is now can be redesigned with the GIELIS Superformula. And that's good news, because it is biomimicry. And biomimicry has a few big advantages over normal technology. And one of the big advantages is energy efficiency. Another big advantage is it's always healthy, because everything is designed in connection to the landscape, to the context, to where it is physically located. Everything is also designed for health. It is also designed for interconnection. And that also means you can redesign big economies with it. And that's where I come in, because my study has been economy and cultures. So that is my specialty. In the meantime, the GIELIS Superformula has been proven for 40,000 growth forms in nature. And that is a lot. That means not only plant shapes, but also how crystals are built, how stones are made, how landscapes interconnect with each other, how well, everything on the earth, how it is done. And that is very important, because we live on a planet. Come on. We need to reinvent everything with this planet in mind and with the fact in mind that we have to be healthy on healthy soil, with healthy water, and whatever makes humans healthy, healthy cities and whatever. So these are the shapes of nature. And this is what the superformula does. So the superformula makes super shapes. And super shapes are really interconnected, and they form and morph and go into other shapes. So everything can be everything and different and whatever. Well, we are here at the Energy Hackathon, energy economy. So how does energy morph into each other? That's an interesting question. And how do economies react with all their complexity, negative feedback loops, positive feedback loops, and everything? Complexity does not have to be complicated. It can be rather simple. So that's what we always try to do, make complexity simple. What is GIELIS? GIELIS is, of course, the name of the discoverer, Johann GIELIS. He is a professor at the Antwerp University, and he has been building businesses. So he's also the technical man behind the antenna company. Everything is an antenna in nature, and everything can be an antenna in the human world, in the human technology, because of its shape. Very interesting fact there. Another thing is that he is a botanist, but he's also a mathematician. And that means that big algorithms can really flow into each other. And that is good news for the economy. GIELIS is an acronym for generalized, intrinsic, and extrinsic length in submanifolds. Well, what does that mean? Generalized is we always generalize everything. I do it in words, and that's why some people accuse me of going too short, taking shortcuts and corners, cutting corners. I am in complexity. Of course I am, because I have to generalize. Otherwise, I can't explain simply about feedback loops and how they all go. Intrinsic means inside a scope. The inside, you are inside a box. Extrinsic means outside the box, so outside the scope. Yeah. In submanifolds, and submanifolds means it is a math term. Submanifolds means it is immersed in each other, and that's where it can morph. That's how it can really morph into each other. Of course, a lot of this is technical. It is beta sciences. So I'll really make it simple, because I also don't understand the deep depth of how it will be used in chemistry for non-toxic chemistry, because we make hydrophobic materials with PFAS and PFOA and all these very toxic for humans elements, and it has to stop. So that's where it becomes interesting to see how nature does chemistry, because nature does it differently. Hydrophobic materials are the materials where water stays on top and does not flow in. Hydrophobic materials are just water plants. They're all hydrophobe, otherwise they couldn't float. Water just goes off it, and oil goes off it. And we can design like nature does it without the big toxicities. And if you want to go deeper into that kind of the biomimicry, go to the Biomimicry Institute, go to asknature.org, and you'll see how it all is different. The biochemistry is different from the normal synthetic chemistry. But of course, we will combine it. We will not say this not, that yes. We have completely done things differently in our world, and there's no turning back. And we don't have to. We can redesign and that is very important. So if you want to experiment, you can go to this link, and then you can experiment with the formula, and I will see that I can share a little bit how that works. Let me see where I am. This one. Yes. This is the program that I showed you. And of course, you can put a lot of metrics in on the right side. But you can also make the shapes at random. Here's the random button, and you can just morph shapes. And if you then, you can really turn shapes. Look, oh, now it looks different. This is what the biomimicry lenses do. It looks different. It sounds different. Everything is different. Shh. This is interesting. So that also means you can cut things. Let me see how I did it last time. Clipping the plane. And then you can make a clip of it, or you can really make a shadow of it. And that is also where it becomes really very interesting, because all these shapes are things you can use in designs of economies, we'll show you, in designs of healthy materials, and in designs of energy. So go and play with it. Go and play with the Superformula, and then we will have the coming 3 days in-depth talks with Johan GIELIS about how to use it for biomimicry design of regenerative areas.